Hi friends, good evening. We- Yeah, so good evening everyone. So welcome to the domain analytics training, that is automotive analytics by 360DigiTMG. And today is the last day. In previous classes, we have discussed about the applications of automotive analytics. Then we discussed about CRISP MLQ methodology, cross-industry business standards for developing machine learning applications with quality. Yeah, there will be 6 stages, starting from business and data understanding, data engineering, model building, evolution, deployment, and monitoring and maintenance. So then, so after we discuss regarding EDA, that is EDA and pre-processing, second step in CRISP MLQ methodology. So whenever we have the data, we need to understand the problem statement. Then we need to note down the business objectives and constraints. Then we can go with the next step. We need to clean the data. Cleaning plays an important role. So after we need to go to the model building step. So model building is nothing but it is so for that we need to discuss regarding the types of machine learning. So there will be 4 types of machine learning: supervised learning, unsupervised learning, and semi-supervised reinforcement learning. And in the model building step, we need to try with various algorithms. So generally, it is completely based on our data set. Suppose if there is no output variable, we need to try with various unsupervised learning techniques. Then if we have the output variable, then we need to try with supervised techniques, and based on the type of output variable, we have different methods. Suppose in our data, if output variable is nothing but categorical, we need to apply classification algorithm. If output variable is continuous, then we need to apply regression. So we need to try with various algorithms, so various classification or various regression model accordingly. Then which model gives good results, so that we need to deploy that model, we need to deploy in the production environment. So after deploying the model, again there will be chances in future, any machine learning application, the accuracy of the model will decrease. That property is nothing but model staleness is nothing but the accuracy, the predicting capacity will decrease. So in that cases, so we need to retrain the model. Yeah. So in successfully we discussed some machine learning algorithms like unsupervised learning. I explain unsupervised learning by using k-means clustering. So in k-means clustering, just clustering is nothing but dividing the data points into the groups. So based on elbow curve, we need to take k value. Then if the new, we can divide, and our entire objective is nothing but we need to divide the data set into the clusters. So the data points in a particular cluster are very similar. Yeah, this is about clustering. Then we discussed about KNN, K nearest neighbor. So K nearest neighbor, K is nothing but nearest neighbors. If we know about your neighbors, we can predict about you. Like, so in our data point, just if the new data, we need to categorize, we need to give a category for a particular data point, just we need to choose the nearest neighbors. So based on the nearest neighbor, we can calculate the Euclidean distances. And based on, suppose if it is between the 2 categories, category A and category B, and category B, 2 data points are nearer to the new data point what I have taken. So then we can say it is belongs to the category like, so KNN we discussed. Then discussed about a decision tree. So it is plays an important role in our daily life also. So we use decision tree concept. Like if you want to take any decisions, so then there will be some procedure like I need to accept that offer or not, what conditions are effective, like that. Same way, in our entire data set, we need to choose one column. So which is we are feeling that it is influencing the remaining data set. Based on that, we need to start. And finally, we can read. So our decisions, we can flow with one by one step. Finally, we can categorize. So that is relation tree we discussed, and after regression. So regression is nothing but it will give the relationship between input variables, independent variables, and dependent variable. If the relation is between single input independent variable and one dependent variable, that is simple linear regression. If the relationship is one or more independent variable with one dependent variable, that is multiple linear regression. So yesterday we discussed it, and there is a use case like the used cars. So what factors are affecting on the cost of used cars, like how much distance it is traveled, what type of fuel, and etc. Yes, so these are the things we have discussed up to now. Now today, we will start artificial intelligence concept. So what is AI first? What is AI? So artificial intelligence, I think that it is the simulation of human intelligence processes by machines, especially computer systems. Computer systems. So it is the simulation of human intelligence, like the development of intelligent machine. The machines will work like think and like a human being. Now the specific applications are nothing but expert system like natural language processing and speech recognition and machine vision. So then let us discuss today what is multi-layer perceptron, how it is important in automotive analytics, and the conclusion. Then after we can do hands-on. So what is multi-layer perceptron? So it is multi-layer perceptron. It is a feed-forward artificial neural network, and generally that generates a set of outputs from a set of inputs. So you can write MLP. So multi-layer perceptron generates set of outputs from a set of inputs. So MLP is simple words. So it is a feed forward artificial neural network. That generates a set of outputs from a set of inputs. And multi-layer perceptron is characterized by several layers of input nodes, so connected as a directed graph between the input and output layer. So let us see how MLP looks like. Yeah. So it is also known as multi-layer MLP, multi-layer perceptron, fully connected dense layer which transform any input dimensions to the desired dimension. It is a neural network has multiple layers. To create neural network, we combine neurons together. So here neural networks will work. So in our brain also there will be a neurons. So each and every neuron is connected. So artificial neuron concept is nothing but how our brain will work. In that same way it will work. Now suppose I have seen one image. So that information is passed to my brain through neurons. And I need to recognize. So in that case, our brain neurons are connected that will process the information. Same way here, neurons will involve. So this is the diagram of multi-layer perceptron. So you can see clearly input layer, hidden layer, and output layer. So in the above diagram, so we can see that there are three inputs: input 1, input 2, input 3, and three nodes. So input nodes and hidden layer output. So the output layer gives two outputs. You can see two outputs are there in the output layer. So therefore we can say here we can have two output nodes, three input nodes, two output nodes. So here how the processing will happen. So the nodes in the input layer, so these three will take input and forward to the further process. So in the diagram, so input layer is forward to output to the each of three nodes in the hidden layer. In the same way, the hidden layer process the information and passes to the output layer. So input layer will give the information to the hidden layer will pass information to the output. And one more point here you need to see. So every node in the multi-layer perceptron uses Sigmoid activation function. So what is Sigmoid activation function? So it takes Sigmoid activation function, takes real values as input and converts them into the numbers as 0 and 1. Now here, whenever if we take the data, so the data point will be loaded to the through inputs, and that will be processed through hidden layer and output. So here we can define epochs. Epochs is nothing but number of times we are training that model. If we write epochs is equal to 15, so 15 times it will train. So the advantage of this multi-layer perceptron is back propagation. So if while we are passing the input through the input nodes, if there is an error, so the weights will be adjusted. So during the second training, so finally the weights will be adjusted, and after that you can get the correct answer. So the all errors will be minimized. So based on the number of epochs. So here this is the same information what I have explained. So the formula for sigmoid function, so 1 plus exponential of -6. So the generally the output is in terms of 0 and 1. So how it is important in automotive analytics? So the best example is self-driving cars. So these self-driving cars are autonomous decision-making systems. So they can process streams of data and from different sensors such as cameras, radar, GPS, or inertia sensor, and accordingly that will process. And here we can have some important in automotive analytics. Multi-layer perceptron is fully connected class or feed forward, and being heavily utilized in the development of autonomous vehicles, which depend on analytic and predictive capabilities for success and safety. So whether how many years after that vehicle will damage. So what factors it is affecting? The lifetime is depending on what factors. So in that way we can analyze. and it is a key in autonomous vehicle as that will collect so input data from the sensors, process, and then produce the correct behavior of the vehicle. So in this way, it is very important. Now let us conclude the discussion regarding multi-layer perceptron. So intelligent devices seems to provide a more proactive intelligent solution for automotive industry. And company like Helios Technologies are similar paths to create deep learning devices that will process sensory data in the moment just as human drivers will do. So this is the best application, and they still work to getting these solution to have the processing power. Yeah. So this is about conclusion. So let us discuss through hands-on. I'm sharing my screen. So car sales, my use case is nothing but car sales forecast with multi-layer perceptron. Just I'm using Google Colab, and the data set contains the number of vehicle sales so realized in a certain period. The number of sales was kept in month, so we will forecast sales number for the next 6 months. So what was sales with respect to month is given. Now our objective is nothing but we need to forecast sales for the next 6 months. So what should be the sales? What are the sales coming 6 months? And that we need to solve by using multi-layer perceptron. So just I am using the data set from the source. So let us run this. So first step, I am loading the libraries. So what libraries are required to solve, like NumPy for arrays, pandas for data frames, Seaborn for visualization, stat models, seasonal, because forecasting tech we are using. So TensorFlow we are using, Keras, etc. So let us run this. It is done. Now I need to load the data. So the data is nothing but salescar.csv. Yeah, so yeah, I need to add the data into this path. Yeah, just here I need to select sales cars, open. That is done. So let us execute this. Yeah, successfully I have loaded the data. So how our data set looking like? Yeah, so this is our data set. So the data set consisting of only 2 columns, month and sale. So 2016 first month sales are 266. Similarly, second month 146. Third month 183. Similarly, fourth month 119. Last month here, I mean fifth month 180. This is our data set, simple data set I have taken. So in this part, we convert that month column to the date to date format. So to convert that month column to date format, so we need to use date time, month format, year and month. So let us execute. Yeah, it is done. So resampling again month sum. Now what should be my data set? So you can see here. Yeah. So first month 31st date 266. Like now what should be the sales chart? So this is sales with respect to the month. Okay. Sales chart. So you can see sales from January 2016 to July. So you can see the sales around 260 and it is decreased again increased. So here this is the graph will show the relationship between the number of sales with respect to the months. Next. Now seasonal decompose. So here you have residual values and seasonal values, trend and sales. So sales graph and trend continuously it is increasing. Seasonality residual. Now here we want to forecast for next 6 months. So we will not able to see the how successful the results are because we do not have actual sales. So what should be the sales? What are the sales after as it is 2016? We don't have actual data, so it is difficult to compare with our predicted results. So therefore, to measure the success of this forecast, I said last 6 months of this test data, I leave the rest as train. So we will predict the next 6 months from the train data and compare with the real values in the test data. Okay, we are splitting train test split. So let us check the train dot head. Next test data. So generate lags nothing but samples. So now train sale values. Here 12 is nothing but number of samples. Done. Now here X. So this is array. These are the different values. Train X. So this is train Y. So last batch values. Okay, fine. So let us build the model. So here I am defining MLP model. Epochs I am defining as 1000. Model sequential dense activation function I am using ReLU. And loss function MSC. So let us execute this. I am model testing the model. So as informed, so epochs is nothing but one epoch is nothing but one time the total data is passed. Take some time. Yeah, it is done. Now let us, so here loss value 1.332. So we raise it to minus 0. Raise it minus 0.9. Rate is less value. So let us forecast. So next we are going to predict forecast function model last batch values. 6 is nothing but number of samples. So let us predict. Yeah, so these are the predicted values. Now test predicted sales. So test predict head. These are the predicted values. So what is the difference between the sales and predicted sales? So these values are nothing but predicted values. So let us see the difference. So you can see the sales and predicted sales. So now let us calculate. Let us calculate the error line by sales and predicted values in percentage in test data. Yes. So column 1 sales, predicted sales. So we are getting the new data frame. Yes. So what is the new data frame? So let us calculate the average error. So here error rate we have 10%, 12, sorry. So now if you want to see, so how many cars sold in reality, in how much are predicted, so we can find the percentage error. So sum of actual sales, sum of actual sales. So 2,808. Now sum of the predicted sales. So the difference of 3,170. So some difference we have. Now let us calculate. So rate of actual and predicted sums. So by the formula, sum of predicted sales into 100 by sum of actual sales. So then here I am using one conditional statement. If rate of actual and predicted value is greater than or equal to 100, then total percentage is equal to rate of actual and predicted sum minus 100. So otherwise, total percentage is equal to 100 minus rate of actual and predicted sums. Let us execute this. Finally, the percentage error is 11.03. So error is less. So it is giving good result. So here what we did, they have given data. So with respect to month and sales. So based on that, we predicted the next 6 months. So let us revise once. Yeah, so today we started. Yeah, so multi-layer perceptron. It is also called as feed forward artificial neural network. So yeah, as I discussed, it has 3 types of layers. So input layer, output layer, and hidden layer. So as I said, just input here we have 3 inputs. So input layer receive the signal to be processed. So what should be analyzed that will be received by the input. And the required task, suppose our data set has to predict or it should be classified. So prediction and classification is performed by the output layer. And here initially when we can pass, so data points, if we have our data set, so the data points are passed to the inputs, then so that are connected to the hidden layer. So then it will give the output. So weights will be adjusted, so you can have the output. So after passing one data point, based on the error, so back propagation, so it will retrain. So as number of epochs increases, then the weights will be adjusted, and finally we can get accurate results. So in this way, so multi-layer perceptron will work. And here in every node, so what we discussed here, in every node, so in the multi-layer perceptron uses a sigmoid activation function. As we discussed it, so sigmoid activation function takes real values, any values as input, and converts them into the numbers between 0 and 1. Like if we touch one hot body, so say the information is passed to our neurons. So there will be input layers, so we are giving contact, so that should be the input, and hidden layers, the information is passed. Then if your neurons will activate it, so then if they pass signal like 0.6 and etc., so it will say, yeah, you need to leave. Yes. So in this, so this is a general example for multi-layer perceptron, and we discuss it. how this multi-layer perceptron is important in automotive analytics. Especially it is very important in self-driving cars. So autonomous decision making system. And we can say a general example, how many vehicles so traveling towards one particular road, and we can predict the lifespan of that motor. So how many years after that will be damaged, and we can some use cases like in supply chain management we discussed in the first class only. So in supply chain management, definitely the goods will travel from one place to another place. But if the goods has to travel between the two locations A and B, if the distance is equal to 700 kilometers, and we need to choose whether we need to whether the vehicle is correct for the journey or not. So we need to predict based on historical data. So historical data will give some information like such company vehicle. So maybe we'll raise some error, some problems after traveling such distance like 350 etc. So based on that, we will not consider that vehicle for our work. So it will work, will give suggestions for us for a future. So what we need to take, what whether we need to accept that or not. Suppose if we accept, then definitely lot of challenges. If it is breaks down middle, we need to connect with different persons who was involved in that, and etc. There will be a loss. So what should be the lifespan of that engine? What should be the lifespan of that vehicle? What are the possible errors, etc. So we can predict. And even, this is the one of the benefit. And so neural networks are making their ways so into various commercial products across many industries. The number of products. So what type of products the people will purchase? So how to increase? So if we of our analysis will give that the people is going to purchase such type of products. So based on that, we can increase the production. So many business decisions we can implement. And as I discussed, intelligent devices seems to provide a more proactive and intelligent solutions for automotive industry. And the companies like Helios Technologies are similar paths to create deep learning devices. So that will process sensory data in the moment just as humans drivers would. What data? So what data they will get if human drivers would get same data we can extract by some sensory devices. And there's still work to do in getting solutions to have the processing power and size required for driving vehicle. But certainly appear artificial intelligence may provide the most human-like solution behind the wheel. So this technology will give a good solution for that vehicle. Yeah. So this is a conclusion. Yeah, friends, thank you for joining the session. So today we discussed regarding how the neural networks plays important role in automotive analytics. So not only this, so it is involving in various technologies, various analytics. Okay, thank you for joining. Have a nice day.